a combination of a certain number of objects, say R objects, which are chosen from n different or unique objects, is given by that formula there. For NCR, remember the short way or the other way of writing it is this one here. Just write that thing. It looks like a vector. That means exactly the same, but the meaning is we're taking n factorial into the numerator and we're dividing by n minus r all factorial multiplied by r factorial. Well, that formula is the same as this. I hope you can see here. You will remember that this part alone is actually equal to NPR. So it's like we are taking NPR and dividing by R factorial. That is why this formula says NCR is given by the number of permutations of R from N. Now that means we're choosing from N, we're picking from N R different objects, and that should be divided by the number of permutations of each set of R. So the number of permutations of each set of R. That is where you will get your R factorial down here. Let's look at example 1, then we'll jump to other examples. The question reads, in how many different ways could a committee of 6 people be chosen from a class of 25 students? So let's make sure that we understand that one first. So we have here a class of 25 students, and we are forming committees, or we're forming a committee. We need a committee out of these 25. Now the committee should be made up of 6 people. So we are choosing 6 from 25. And so the question is, in how many different ways can we do that? So when you read this question, you should understand, obviously, that this is not an arrangement. We are not asking in how many different ways those students can be arranged or can stand in a line or can sit in a line. We are asking how many different ways can we form a committee of 6 from 25 given students. So imagine 25 given students. I don't have enough space and time to show you an example, but we have 25 of these students sitting there. So 25 of them, and we are forming committees of 6. So we could take anybody into the first group of 6, and we can actually form so many different committees with 6 people inside. So that is what the question says. In how many different ways can we form a committee of 6 from a group of 25 people? And to answer this question, you've got 25 people to choose from, and you are choosing 6. Maybe this is the easiest way to understand this question as it is right now. Right. So look at this and let's go back to that formula there. We said a combination, I'm reading from here, a combination of R objects. So we're combining R objects that are chosen from N objects. And that is given by that formula there. So this is exactly what we are doing. We're looking for a combination of 6 students that are chosen from a group of 25. So the answer is 25C6. You can put this in your calculator and get your answer straight away, or you can apply that formula there. The formula says n factorial, which in this case will be 25 factorial, divided by r factorial. R factorial will be 6 factorial in this case, then that should be multiplied by n minus r. N minus r, that is 25 minus 6. So 25 minus 6 will give you 19. So that would be 19 factorial. If you're working it out without a calculator, maybe that is where you could start. But otherwise, feel free to put 25C6 into your calculator and get your answer. This is actually where you get that answer there, 177,100. Let's look at number 2 there. There are 13 people that are waiting for a taxi to transport them to work. You can imagine that. People are waiting for a taxi to take them to work. The taxi then arrives, but it can only accommodate 4 passengers. So only 4 people can go. Out of the 13 that are there, only 4 can go in. So we want to know in how many ways the 4 people can be chosen to get into the taxi. So again, make sure that you understand the question. From the group of 13 people, we combining them in 4s. And there are many different ways of grouping them in 4s. And using that formula there, you will get your 13C4, which will give you 715. So there are 715 different groups of 4 people that we can put aside to go into this one taxi. We're not saying 715 people will go into the taxi, but we are saying there are 715 groups of 4 that can go into the taxi. Example 5, a committee of 5 people is to be chosen from 6 men and 4 women. So let's take note, we have 6 men and we have 4 women, but we want to choose a committee of 5. We just need 5 people on the committee. Now the question says, in how many ways can this be done? If there must be 3 men and 2 women on the committee. So we want 3 men and 2 women. Remember, 3 men and 2 women will actually make 5. Remember, our committee should have 5 people, but in this particular case, we want 3 men in there and 2 women in there. Right, so first of all, in how many ways can you choose the 3 men? You are obviously choosing the 3 men from the 6 men. So it is from the 6 men. I want to show you another notation. I haven't used it yet. So from the 6 men, we are actually choosing 3. So this is how we said you can write it. Instead of writing NC3, you can write 6-3 like that. Now that is the number of ways in which you can choose 3 men from 6. And in how many different ways can you choose 2 women from the 4 women? So we have 4 women and we're choosing 2. So that is how you get your answer of 120. Right, now number 2 says, in how many ways can this be done? Remember, we still want 5 people on the committee. So in how many ways can this be done if there must be more men than women on the committee? More men than women. Now, out of the 5, remember, we have 6 men and 4 women. We want more men than women. So that means we could actually have 5 men and 0 women. That is obviously more men than women. If you have 5 men and 0 women, then we have more men. Or we could have 4 men and 1 woman. That is still more men than women. Or we could have 3 men and 2 women. We still have more men than women. And I think that is all. And so what we need to do is work out the value of this, or the number of combinations where there are 4 men and 0 women. Then work out the number of combinations for 4 men and 1 woman. Work out also the number of combinations for 3 men and 2 women. And add up those different answers. I've done it already, so I'll show you what I did. This here gives us the number of combinations for choosing 5 men and no woman. So if you want, I'll put it here again. It's from 6 men, we are choosing 5 men. But from the 4 women, we are choosing 0. So that is the first part for that part. Then we need to add this to the next possibility. We could actually choose 4 men out of the 6. So out of the 6 men, we choose 4. But out of the 4 women, we need 1 woman. That is why I've got that one there. And then finally, we actually could have 3 men and 2 women. Now the 3 men are chosen from 6. So we're choosing 3 from 6. And the 2 women that we need to choose are chosen from 4. So that is 4 choose 2. Take those numbers, add them up together, you should get 186. And question 3 says, this time we still want a committee of 5, but we want, there must be 3 men and 2 women. But the question says there is one particular woman who refuses to be on the committee with one particular man. Now that is very important. So one woman does not want to be on the same committee with one particular man. The strategy to answer this question is work out the number of combinations. This is where I am. Work out the number of combinations without any restrictions. Like without any restrictions, we are saying we just want a committee of 5. And we actually did work that one out earlier on, because how many people are here altogether? We said there are 6 men and 4 women, so there is a total of 10. So if there are no restrictions, the question says we need 3 men and 2 women. So suppose there were no restrictions. The restriction here is this woman cannot be on the same group with this man. So that is the restriction. But if there was no restriction, it was just going to be any 3 men and any 2 women, which we did in part 1. And we said that was 120. So you take that is the number of combinations without any restrictions. And then you need to subtract the number of combinations when these 2 are actually together. The question says they should not be together. And so we need to find in how many ways they can be together. Then we subtract that from the number of combinations without any restrictions. So for the number of ways these people can be together, this is what it means. So that man should be there. That means we're choosing that man in only one way. But remember, we need a total of 3 men, so we need to choose 2 more men from the remaining 5, which is why this would be 5, 2. But the woman also can be chosen. This woman should be there no matter what. But we need 2 women altogether. That means we need 1 more woman in addition to this woman who is here already. But the 1 more woman that we are picking is actually now picked from the 3 that are remaining. So that is 3, 1. So if you simplify that, you should get an answer of 90.